All right, well, why don't we get started, everybody? Good day and welcome to our Tech Tuesday webinar on incubation guidelines for popular broiler lines. My name is Mark Sintel. I'm the Vice President of Customer Care for Chickmaster, and I'd like to welcome everybody. And while we can't see each other in person as easily right now, we are really honored that you would choose to join with us virtually to talk about broilers. And today's a really special day. I'm particularly honored to be able to welcome our partners from Cobb and Aviagen. And so I'm going to ask Chad Daniels, the leader of our hatchery specialists, to introduce them in just a moment. Chad, would you, if you're on, would you introduce our guest, please?
Yes, good morning, everyone. Thanks for joining us. It's one of these webinars that we've looked forward to for a good period of time. We think it's a great topic and obviously one that a lot of our customers are very happy to be involved with. So to begin with, we have Tommy Lively with us presenting Cobb. Tommy has over 27 years in the poultry industry. He has experienced in the past positions such as being a broiler manager, breeder manager, and manager of hatcheries, both in the broiler and primary breeder level. Tommy joined the Cobb World Tech team back in 2017 and spends a lot of time in the U.S. market and Southeast Asia as well, and in other countries, representing Cobb as a hatchery specialist in order to help people fine-tune their hatcheries and get them to perform better. So with no further ado, Tommy, I'm going to turn this over to you, and you can begin your presentation. Thank you.
Good morning, everyone. Very happy to be here. Really appreciate Chickmaster and Chad inviting me to come and talk to everyone this morning. As Chad said, my name is Tommy Lively. I've been here in the U.S. industry for over 27 years and spent a lot of time in hatcheries. And today I'm the one of the hatchery specialists for Cobb, along with Scott Jordan. We both work out of the U.S. here, and we have responsibilities all around the world. And we see many chicks being hatched in Chickmaster machines. Chickmaster machines are very popular around the world. We see a lot of our birds in them. And so when we go out and talk to customers and look at hatcheries, we have a lot of factors that go into chick quality. We could do an all-day presentation on chick quality factors, but we're not going to do that today. We kind of limit those factors that we talk about to incubation temperature. And when we talk about incubation temperature, we're going to spend a lot of time talking about eggshell temperature. We're also going to talk about incubation humidity or moisture loss in the machine. And of course, the incubation humidity is the primary driver of moisture loss. We're going to spend just a brief moment on turning, and then we're going to talk about chick body temperature and chick holding time. Also, if you have any questions that we don't get to today, feel free to send them to me. You can work through Chad and Chickmaster, and they'll get the questions to me, and I will get them back to you as quickly as possible. So chick quality eggshell temperature. So eggshell temperature is going to control the speed of embryo development. It's going to affect your moisture loss, your chick length, your chick quality, and your hatch percentage. We all know that temperature is the main driving factor in hatch and chick quality. Generally, everyone considers 100 to 100.5 to be the perfect eggshell temperature from day 3 all the way through transfer into the hatcher. So that's what we're shooting for. We also know that it's impossible in modern large incubation machines to keep the eggshell temperatures 1.5 degree range. It's almost impossible to do that. And so we typically see a range of 1.5 to 2 degrees at day 17 or 18 of incubation. We're producing a lot of heat. The embryos are producing a lot of heat at that point. And so we see a range of eggshell temperatures that we're going to have to deal with. What we have found in our research with our Cobb lines is that eggshell temperature is really negatively affects hatch and chick quality when you go below 100 very quickly. And we really don't recommend anyone going below 99.5 on eggshell temperature towards the end of that period in the hatcher, in the incubators. So we would want you to start that range around 99.5 and then work up from there on our lines. When we talk about checking eggshell temperatures, the Exergen tools work very well, but the Braun ear thermometers also do a very good job, and that's the tool that I usually use today when I'm checking eggshell temperatures. Where to measure the eggshell temperature, we encourage everyone to measure it just below the midpoint of the egg. We don't want to be up on the air cell at all. And you can see here where the blue arrow is on this presentation. how that air cell slopes when you lose the correct amount of moisture. And so if you check it too high, you could very easily get up on the air cell, and you're going to get a much lower reading if you're up on that air cell when you're trying to check for eggshell temperature. In Chickmaster multi-stage machines, we would typically check top, middle, and bottom of eggs at around 18 days of incubation, and we would do that at the back of the machine, the middle of the machine, and towards the front of the machine as well. We want to check all the areas of the machine to make sure the machine is in balance and to see if we have any hot or cool spots in the machine. And that's what we're looking for, is to make sure the machines are in balance and they're at the correct temperature. Typically at each one of these spots, front, middle, and back, top, middle, and bottom of this machine, we would check 3 to 4 eggs, and we would make sure we're not checking that front row of eggs right at the hallway there. We want to move back into the egg pack to check to make sure that our temperatures are correct. With single stage, we try to stay out of those machines and keep them closed up as much as possible to keep the machine in balance. And these tiny tag readers, and there's several other companies out there that make similar devices, do a very good job of recording eggshell temperature. You can simply attach them to the eggs and use them throughout the incubation period to monitor your eggshell temperature. And it's just a really good tool to make sure your eggshell temperatures are in the range you want them to be in. On the Chickmaster multi-stage machines, we would recommend the range of eggshell temperatures to be roughly 99.8 to 100.2 on the low end. So you're going to have a range, and we would want that range to be around 99.8 at the lowest point. The typical set points that I see for Chickmaster multi-stage with Cobb flocks in them are 99.4 to 99.6. Those are the typical set points that I see. I'll see a lot of people at 99.5. If you have really high fertility, if you have good fertility in your flocks, or you have sold off older flocks, you may go as low as 99.3. I really don't encourage anyone to go below 99.3 unless it's a really extreme situation. And if your fertility is lower, or you have a lot of old flocks in the machine, you may be as high as 99.7 to 99.8. You just have to really monitor your eggshell temperatures and adjust based on what they're telling you. On single stage, I would just encourage everyone to adjust your profile so that you have no eggshell temps on live embryos below 99.5. So you'd want that to be the low end, and then to work upwards from that point. So check around day 18 and just make sure you adjust that profile so that 99.5 would be the low end of your range when you're looking at eggshell temperatures. So just some data here on what that's going to cause. You see, as far as hatch percentage on this trial that we did, hatch was really maximized at 100 degrees, and we really didn't hurt hatch up to 102 degrees. We didn't change hatch significantly at all. But when we went to the low side, when we went all the way down to 98.5, you see what it did to hatch. It really significantly affected hatch. And so that's the reason we would encourage you on single stage not to play below 99.5. You start dropping off very quickly if you get them too cool. The reason you don't want to go too hot is really easy, just to crank up the temperature and get every chick. But the reason you don't want to go too hot is you see in this graph, when you're at 100, cull percentages are minimized. You get the fewest number of culled chicks at 100 or just above. When you get up to 102, you see significantly more culled chicks. And when you go down to 98.5, you see a lot more culled chicks. So that's the reason we encourage everyone to be in that 99.5 range or up, to stay as close as we can to 100, which we would consider to be perfect for our breed. Moisture loss. So moisture loss is the second biggest factor when it comes to chick quality and hatch. It plays a huge role in both your hatch and your livability and your chick quality. So moisture loss is affected by eggshell temperature as well. You see here on these graphs that when we go low on eggshell temperature, we lose significantly less moisture, and that's the reason for the increase in culled chicks. When we go up to 101.5, it really doesn't change our moisture loss that much, but we're still getting good hatch and good chick quality all the way up to 101.5. Once again, the 100 to 101.5 is the range we want to be in, and that's where we're going to maximize our chick quality and our chick length. This graph is showing chick length, and you see when we go cool, it really affects the chick length, and it will cause poor chick quality and poor performing broilers as well. So transitioning into moisture loss. But insufficient moisture loss can affect red hawks, chick yield percentage, and 7-day mortality and body weights. Moisture loss is controlled by eggshell temperature and the relative humidity between set time and day 18. Moisture loss should be measured weekly in each type of machine that you have, so that you're monitoring the levels that you're achieving. If a chick loses the correct amount of moisture, it will pip on the largest part of the shell and cut straight around. So that's the big indicator. We want to look at that number. We want to weigh eggs in the egg room and again at transfer. But we also want to look and see where those chicks are pipping. If they're pipping too high or they have red hawks, that is really an indication that they're not losing enough moisture. So our moisture loss targets for Cobbs, multi-stage setters are slightly higher than the single stage machines, but not a tremendous amount of difference between the two. But these are the targets that we set and that we put out in our hatchery guide. So 25 to 30, around 10 to 11%, all the way up to 13% plus on multi-stage machines on motor flocks. On single stage, you have as low as 10, and as high as 12.5% on single stage machines. So there's a slight difference there, but we don't expect it to be a really large difference between single and multi-stage machines. As I mentioned, if you don't achieve enough moisture loss, you're going to pip high on the shell, and that's going to equal red hawks as those chicks struggle to get out of the shell. Correct moisture loss should look something like this. You'll see a larger air cell. You'll see that chick down in the shell, and you'll see the chick pipping at the correct level and cutting straight around that shell. That's what we're looking for. So with proper moisture loss, your air cell is going to slope at day 18. It's not going to be like this guy in the little picture here. He's not going to pip high and kind of slope down. He's going to pip the middle of the shell and cut straight around. If he does like this guy does, he's going to have red hawks. So moisture loss, the reason it causes so many chick quality issues is it's directly related to chick yield. But if moisture loss is too low, chick yield will be too high. You won't lose enough moisture. You'll end up with a big bellied chick that has to pull in a big yolk sac, and you end up with a shorter chick. We would encourage you to check chick yield occasionally, but if your moisture loss is correct, your chick yield should be correct unless you're really dehydrating the chicks in the hatchers. So another graph here on some trials that we have done. So when we're at 100 degrees, that is where we get the correct chick yield you see in the blue line, and you see that 7-day mortality is minimized at that point. When our temperature is low and we get poor chick yield or too high a chick yield, we're going to have really high 7-day mortalities. And when we go higher in temperature, it's going to affect us, but not nearly as much as when we go low in temperature. The blue line here is the same, the chick yield is the same, but now we're looking at 7-day body weights. And you see when chick yield is way too high, our 7-day body weights are going to be way too low. When chick yield is correct, that is where we're going to maximize 7-day body weights. So chick yield and moisture loss play a big role in our broiler performance once we get these birds in the field. So weight loss recommendations, weigh eggs and calculate moisture loss daily. So you don't have to do every machine every day, but do a sampling of the machines and adjust your humidity and damper openings as needed to hit targets. In most Chickmaster multi-stage machines, I see people having success around 81.5 to 82.5 wet bulb in those machines. I have seen folks above that and below with good chick quality, but really 81.5 and 80 to 82.5 seems to be the sweet spot for wet bulbs on Cobbs in a Chickmaster machine. Make sure you focus on chick quality and learn the percent moisture loss that gives you the best results in your hatchery. There's a lot of different factors that go into chick quality, fertility, flock ages in the machines. And so you really have to focus on your chick quality and make adjustments in your hatcheries to maximize your results.
Hey, Tommy, real quick, before you move on to turning angles,
Okay.
In that last slide, you said we should calculate, weigh eggs and calculate moisture loss daily. Someone's asking whether there's any specific days that they recommend temperature checks for single stage or multi-stage.
In multi-stage, we would encourage you between really around day 18 to check eggshell temperatures, as we talked about in the back, middle, and front of the machine, top, middle, and bottom. So around day 18 to see, and and you're checking live embryos. Make sure you're checking live embryos at around day 18 to see how much heat you have in your machine, and you adjust your temperatures really based on that, within reason, of course. Yeah, with single stage, I really encourage people to use some type of tiny tag or other device to check temperature, eggshell temperatures without opening the machine. If you do not have that, you can go in when you start embrex. So make sure the door gets shut right back, but you have it opening when you take a rack out, and you can get in there and check eggshell temperatures at that point when you start embrex. Make sure you're checking inside the machine, because once you pull those eggs outside, they're going to cool off pretty quickly.
Great, thank you.
So turning angles, we recommend 39 degrees at least on the Cobbs. That seems to give good results if you can achieve that. Calculating the hatch window and really knowing how early your birds are hatching is really critical with the Cobb lines. It's very easy to overheat these chicks in the hatchers. And so we want to make sure that we're hatching and we're getting those chicks off so that we're maximizing our hatch, but we're also not hatching them too early. The goal of a pre-pull assessment is to fine-tune your set times to reduce dehydration and improve overall chick quality. During the pre-pull assessment, we would also encourage you to look at those pip lines and use that to help you judge your moisture loss. And that's the point that you would also begin taking cloacal temperatures. And I also like to look for transfer cracks at this point. You're digging through those trays, you're looking at pip lines, you're looking at chick quality, and it's also a really good time to look for transfer cracks while you're in the machine. So how do we perform a pre-pull assessment? We would want to go in 12 hours before we expect to pull that machine. So if we're planning on pulling that machine at, let's say, 5 a.m., we would go in at 5 p.m. the day before, and we would have specific trays that we're going to count the number of chicks out. Be consistent. If you use a V pattern, always use a V pattern. We very often will simply count the fourth tray down. That seems to give a good average of what's in the machine. We would also encourage you to do this at 24 hours and 12 hours. So you count them chicks at 24 hours, count them in at 12, and then again at pull. And that's going to give you a really good picture of what's going on with your hatch and how early the birds are coming off. Those identified trays that you count should represent the top, middle, and bottom of the setter rack. So hopefully at the 24-hour pre-pull, the tray is going to look something like this with not too many chicks out. This is what we're going to be looking for. We would expect from multi-stage machines 24 hours prior to pull around 25 to 30% of the chicks out. And on single stage, around 10 to 15% of the chicks out. Single stage is going to have a much tighter hatch window, or should. And so we would expect fewer chicks out at that 24-hour window. At the 12-hour window prior to pull, 70 to 75% of the chicks should be hatched on the multi-stage machine, and roughly 60 to 65% on a single stage machine. So this picture is one that I took a couple years ago, and you can see how high the chicks are pipping on these eggs. They're pipping really high, and they're going to have some really poor chick quality because of this. They didn't lose nearly enough moisture. So I would encourage you to check this when you're doing your pre-pull assessment, and make sure you're not getting too many chicks doing this, because it will really affect your quality if you're seeing this. At the pre-pull assessment, we also want to begin looking at cloacal temperatures. So we want to start checking chick cloacal temperatures to make sure they're in the correct range. You see in the picture on the left, 104 degrees is really what we're targeting. That's pretty much perfect right there. On the right, these chicks are all the way up to 106 at 12 hours before pull. And so we know by pull time, they're going to be really hot unless we really turn this machine down. So moving on to hatcher temps. At day 18 to 18 and a half, the embryo needs a slightly higher air temperature than it needed in the setter. So in single stage incubation, you actually may move your temperature up when you go from the setter to the hatcher. That's very common for people to do that with their profiles. If we have temperatures too high though at this point, as they're transitioning into the hatcher, you can cause many large navel buttons. You'll have large navel buttons that really affect the chick quality. And if you have temperature too low as you transition into the hatcher, you'll see many small navel buttons, which can also affect your 7-day mortality and your broiler performance. So your hatcher temp really has to be tied to the percentage of chicks hatched. A hatcher temperature of 98 to 98.5 is recommended at transfer. And then after 100% of the chicks have hatched, the machine just becomes a holding cabinet, and it must be turned down dramatically to prevent chicks from overheating. So check your cloacal temperatures and find your go-to temperature that keeps those temperatures around 103 to 105 once all of the chicks have hatched. Normally, we find that to be between 93 and 95 degrees once 100% of the chicks have hatched. So we would recommend going in around 98 to 98.5. And then once all the chicks have hatched, you'll have that machine turned down to around 93 to 95 degrees. Large navel buttons, as we were talking about, that's kind of what they're going to look like. And that's where the abdomen is just trying to close too quickly. It's trying to absorb that yolk sac too quickly. And you're going to get that large navel button because of that. It's simply trying to close up too quickly because of too much heat in the machine. Small navel issues are like this in this picture. We would typically see a lot of these if we go into the hatcher too cool. And I define too cool as anything 97.5 or below.
Hey, Tommy, just while you're talking about naval quality there, or issues related to that, we have one of our guests asked, what are other main causes of yellow navel check?
We would usually define that as a leaky navel. So you're just getting a little bit of moisture leaking from that navel, and that can be due to temperature in the hatcher being too high or too low. So it's kind of hard to be specific. And it can be due to insufficient moisture loss. If you're trying to pull in a really big yolk sac because you didn't lose enough moisture in the incubator, that can affect those numbers as well.
Okay, and kind of related, but what causes omphalitis and open navels?
Omphalitis can really be due to insufficient moisture loss. So your moisture loss is too low. That can really lead to omphalitis because you can get infection of that yolk sac when it's so large and has so much fluid left in it. Open navels can be due to both insufficient moisture loss or high or low temperatures in the hatcher. So there's a lot of factors that can go into that. Omphalitis can also be caused by dirty hatcher trays. So we want to make sure those hatcher trays those baskets are really clean. Open navels, you can pull chicks too early and cause some open navels. That is typically not a problem I see. Usually people are on the other end of the spectrum. They're pulling birds too late, but you don't want to go too early either. If your hatch is late, they're not coming off as quickly as you would like them to, and you're pulling them green, then you can have some open navels there as well.
Very good. Thank you.
Okay. So hatcher cabinet temperature again. Once again, we'd recommend going in at 98 to 98.5, somewhere in that range. And then once you get about 25% of the chicks hatched, you would begin profiling down. And when I say profiling down, this is a very slow, gradual process. So once about 25% of the chicks have hatched, we would recommend turning down around 0.5 degree, or beginning to turn down at that point. And once 100% of the chicks have hatched, we'd want to be around 96 to 96.5 when 100% of the chicks have hatched. And from there, we're going to be very aggressive. We're going to turn that machine down aggressively because we're just turning it into a holding cabinet at that time. So it's really dependent on the hatch percentage or the percentage of chicks out more so than on the timing. So we want to make sure we're not just turning the machine down at 480 hours. We want to make sure that we have 25% of our chicks out when we begin to do that turn down. This is what we would expect to see as far as hatch window between a single stage and a multi-stage machine. The single stage hatch window is on the left, that graph. We would expect it to be very steep and to come down very quickly. And then on the multi-stage machine, we would expect it to be a wider hatch window and take longer to get those birds off just because of the variation within the machine. And that is for any multi-stage machine. The Chickmaster machines are probably better than most that I have seen multi-stage wise. The Chickmaster hatch windows in multi-stage can be very tight if they're really well managed. So I'm a big fan of the Chickmaster multi-stage actually. Going back to our profile again, I tell everyone that when I give them this profile, this is a starting point. And everyone's profile is going to end up being different based on the percent readies that they have in the machine and their total hatch percentages. A lot of different factors going into this. So I would not expect everyone to take this profile and to just run it across the board, but it is a good starting point, and it gives you an idea where you can begin looking at setting your temperatures going into the machine and where you should be at the end when you kind of turn that machine into a holding cabinet. Caloical temperatures, As I said, I would begin checking cloacal temperatures at the 12-hour pre-pull assessment. We always recommend using a rectal probe to check cloacal temperatures. It gives you a very accurate reading. It's pretty quick and simple. We don't want to be up here at this 105.4. We don't want to get them that hot. We do not recommend using ear thermometers. I've seen a lot of people try to use ear thermometers to check cloacal temperatures, and they're just very erratic, not consistent at all. And I've tried to use them myself. I have worked with them a lot myself, and I cannot make an ear thermometer be as accurate as I would like it to be. Usually my readings are 1 degree to 2 degrees lower than when I actually use a rectal probe on the chicks. When the chicks begin to pant in the hatchers, when they hit 106 degrees rectal temperature, they're going to start panting, 41.1 C. And when they start panting, dehydration really begins at this point. So we want to make sure we don't allow the chicks to pant. We really want to keep them below 105. So 104 to 105 is the range that we would encourage everyone to stay in. At hatch day, 2 pictures here. The one on the left, you see the chicks are panting. They're around 106 degrees rectal temp. The chicks on the right, they're just laying down. They're kind of flat and lethargic. These chicks are actually above 107. Once they get really, really hot, and then they've panted for a long time, they'll just lay down. So don't just assume that because the chicks are down in the trays that they're happy and feeling good. If you get them really, really hot, they just kind of collapse after they've panted for so long. So the cloacal temperatures, as I said, begin checking at the 12-hour pre-pull. Check again in the hatchers just before pull to make sure that go-to temperature that you've set in your hatchers is where you want it to be. If you're going down to 94 and you're still finding chicks above 105 rectal temp, then go on down a little lower. If you're at 94 and the chicks are in the correct range, then your set point is correct. Check the chicks again in the pull room. We see a lot of chicks getting overheated in the pull room, and then check them again just before loading for transport to the farms. And then I really encourage everyone to check rectal temps again once they get to the farm. Before you unload them, before they come off that truck, check them again to make sure that truck, or however you're transporting them, is doing a good job of controlling the cloacal temperatures on that ride to the farm. As far as pull and handling, I always encourage everyone to pull chicks based on readiness and cloacal temperatures, not on, hey, this is the youngest flock, we want to pull it first. Ideally, the chicks will be ready to pull roughly 2 hours before the expected pull time. And you should stagger your set times so that not all the chicks come off at the same point. You need those set times staggered so that you have some of the chicks that are still green when you begin pulling, but are ready to go by the time you get to them. Placing chicks too fresh will cause elevated 7-day mortalities. I hardly ever see this though, but it can happen. So it is best to have the chicks on the farm approximately 6 hours after they are ready to pull from the hatcher. So we'd expect them to be ready to go in the hatcher 2 hours before the pull time. And then we would expect them to have 2 hours in processing and really just sitting on the pull room floor or the holding room floor, and then 2 hours in transport to the farm. So a total of 6 hours from when they're ready to pull until we get them to the farm is the perfect conditions. Now we know that almost never happens, but that should be our goal and our target. That's what we should shoot for, is about 6 hours from when they're ready to go until we get them on the farm. We don't want them there too green, but that's not normally the problem. Normally the problem is we get them there too late and they're starting to dehydrate by the time we get them on the floor in the farm. As far as the QA program, moisture loss averages, and I'm talking averages here, with single stage around 11.5 to 12%. Multi-stage, it's going to be slightly higher at 12 to 12.5. Eggshell temperatures in single stage are really, in general, 99.5 to 101.5 would be a very good range for eggshell temperatures. Your hatch window, as we discussed before, and then check your cloacal temperatures of those periods that we mentioned just earlier, 12-hour pre-pull and just before pulling the hatchers being 2 of the more critical times. So guys, I ran through that really quickly. Hopefully you learned a little bit what we recommend with the Cobb lines in a Chickmaster machine. And like I said earlier, if there's any questions, you guys feel free to reach out to me, and I'm always available to respond to any questions that you have.
Yeah, Tommy, thank you. But man, super informative information here. Great presentation. And I love that, obviously we want to, we can show how a chick master works, but how the right conditions for your lines, I know is just invaluable information for our customers and yours together. I have a question here. Any ideal chick weight loss during holding in the chick room?
No, I don't really have a specific number for that. I mean, we want to minimize it as much as possible. We don't want to, most of the hatcheries that I visit are not in super high humidity areas. Super low humidity areas. So most of the hatcheries that I visit have enough humidity just in the air that they don't have to add a lot to their holding rooms.
Right.
But if you do have really low humidity, you may want to add a little humidity to the holding room. But 60-65% is fine. We don't want it to be too high or too low, just in a good comfortable range.
Right. We have a question. I know this is a more of an industry topic, but if there's anything Cobb specific that you want to speak to, any views on early feeding with the Cobb lines?
We have done a relatively large amount of research on that and haven't seen big advantages to it. If you're able to meet all the parameters that we talked about in my little presentation here, we don't feel like you get a huge advantage to early feeding. I know that is a big topic in the industry, and I think it's something I'm very happy that people are working on that, and I think eventually it may prove beneficial, but at this time we don't see a huge benefit in it.
Okay, thank you. All right, and a lot of our guests are expressing thanks and appreciation for the information you're sharing. So, Chad, do you have any comments from the Chickmaster side and your experience with Cobbs, or would you like to turn it on over to Eddie?
No, I think Tommy, I think you did a great job. You covered obviously a lot of the topic area, and have several questions that'll need to be answered later. But yeah, I think at this point, I think we're ready to move on to Aviagen.
Okay, well, thank you, Chad. I appreciate the opportunity, you guys, and I'll hang on here. And if you guys have any questions, just feel free.
Thank you, Tommy. All right, at this point, I would like to go ahead and introduce. We'll switch over to our Aviagen representation, and I'd like to go ahead and introduce you to Eddie Van Leerde with the Aviagen. He is the incubation specialist for the global Aviagen hatchery development and support team. He has responsibilities to support Aviagen hatcheries globally, along with customer service teams in the U.S., Canada, and Latin America. He also serves as the liaison with incubator and hatchery automation companies, ensuring open and proactive communication with these important business partners. Eddie's experience is very detailed and in-depth. He currently lives in Huntsville, Alabama, and works out of the corporate office there for Aviagen, and has since 2011. Previously worked in New Zealand for Ross, which is now currently known as Aviagen New Zealand. And he moved to Australia then in 2008. So Eddie began his career as a chicken sexer, managing sexing teams in various European countries. And so with no further ado, I'd like to go ahead and introduce you to Eddie. And Eddie, at this point, you can begin your presentation.
Good morning, everyone. Afternoon, good evening. Thank you, Chad, for the introduction. Again, hello to all the customers. So I was asked to talk about incubation guidelines on Aviagen's broiler lines. Tommy did a good job. He's given most of the principles of incubation, so I can cut this a little bit shorter. And let's get into it. So to make sure everybody is with us during the presentation. I noticed some people came in late, so just quickly go through the principles of incubation. So we need to control temperatures during incubation. We also need to control the humidity levels, oxygen and carbon dioxide as well, and definitely turning, which is many times underestimated. The most important thing with temperature is during incubation, it will determine the speed of the development of the embryo. So if we can maintain the optimal embryo temperature during incubation, we optimize the balance in supply and demand of nutrients for the embryo. So in the last 20 years, research on poultry has gone up tremendously. So we know by now, kind of, what is the best temperatures for our embryos to produce the best quality chick. So also maintaining uniform temperatures within your machines during incubation is very important. So if we have colder spots and warmer spots, the development will be different. So when we come to the hatcher phase, we're going to have issues. So very important. Humidity levels, well, the egg needs to lose a certain amount of moisture during incubation, and this will create the air cell. The relative humidity in machines creates the driving force behind this, okay? So this will help us having the correct moisture loss. So for us, it's simple. For our breeds, we always recommend a moisture loss at 18 days between 10.5 and 12.5%. Now, when I say 18 days, you measure the egg weight at the beginning of the incubation, and you have to measure your egg weight at 18 days. So if you transfer at 19 days, you probably will have to make an adjustment in your formula and go back to 18 days, which is simple, and you can see in our how-tos. At takeoff, we'd like the chick weight to be around 67 to 68% of the fresh egg weight at set. Again, I say at chick takeoff, not once the chicks have been taken off for 4 or 5 or 10 hours. It is when you pull them from the hatcher. Oxygen and carbon dioxide, we know that the embryo needs oxygen, but it will produce carbon dioxide. So the machines need to exchange the air in a proper way to provide the necessary levels. The amount of CO2 produced by the eggs will increase with embryo age. So ventilation during incubation becomes very important. Turning, we recommend your turning should be at least 38 degrees, ideally 45 degrees. Now, you might ask, why do we say 38 degrees? Because we know that some machines won't even make 45 degrees. When they are new, they will probably only start around 41 degrees. I also put this in because we know in the multi-stage machines, when they get older, turning becomes less and less good. So beware, have a minimum of 38 degrees. If not, you will lose hatchability. Also, we'd like to have smooth turning. So we don't want sudden movements because in the end, inside those eggs are little embryos and we need to take care of them. But also very important is having even turning angles throughout the machines. Because if we have uneven turning angles, like let's say on one side is 38 degrees and on the other side is 46 degrees, the air will always look for the easiest way. So then some of your eggs won't get enough ventilation and the temperatures will start to be different. So just a little bit more on temperatures, because this is really important. Our team, and this is the hatchery support and development team of Aviagen, conducts a lot of incubation trials at our trial facilities. But we also work closely together with universities, different professors, and also with incubation manufacturers, because we want to make sure that you get the best. So we want you to have the best advice and as accurate as possible, so we help you as a customer to bring out the genetic potential of our breeds. So one of our temperature trials, which I also did for a couple of years when I started in this team, is about eggshell temperatures. So we start off with an ideal eggshell temperature of 100 degrees Fahrenheit in one of the machines. And then after 10 days, we change the eggshell temperature to higher temperatures just to see what the effect is. So this is our trial facility in Albertville, Alabama. Yes, it is Chickmaster machines, and I've had a lot of fun with these machines. They have taught me a lot. So eggshell temperatures during the second half of incubation, as I mentioned before, we increased it into a machine, into 2 of the 3 machines. We kept one machine at the ideal 100 degrees Fahrenheit. So what did we see? And I won't put hours on this because we have different breeds. When the machine at 100 degrees Fahrenheit, we ended up with the normal incubation time, which was around 504 hours. but we increased that temperature in the second half of incubation. Those chicks were hatched 24 hours prior. However, that went to a cost. We see that the high incubation temperature gives us a huge depressed hatchability. So no good. A lot of the industry is looking is, what is my hatchability? Okay, but the second thing is, we also increased our culls. Even at 101.5, we had a higher cull rate compared to the 100 degrees. So in other words, this 100 degrees eggshell temperature for our breeds is best. High incubation temperature also gave us smaller chick. So the chick, yolk-free body mass chick weight was lower with a high incubation temperature. So that chick was not developed as it should be. The heart sizes were smaller, and then we hear customers, they have problems with ascites. Proventriculus and gizzard were also small. And we also see that there was a decrease in small intestines. This was a work done by my former colleague, Dr. Lexri Sompon. So it's simple. Eggshell temperatures, where you see the green band, this is what we see as ideal. And this is for all our breeds, whether it's a 708, a 308, a 308AP, an Arbor Acre, or an Indian River. These are our recommended eggshell temperatures during incubation. So how do we manage this? Well, in single stage, it's pretty straightforward. We measure and adjust the temperature profile as the embryos develop. So we can measure these eggshell temperatures during the incubation, and we will adjust our machine profile. So when you buy a machine from Chickmaster, it will come with a set profile. A lot of people tend to forget, when you buy this machine, you also own the program. You can change that program to the needs of the eggs in your machine. So go and measure eggshell temperatures and adjust your profile accordingly. Manufacturers also are becoming more and more technical, and they sell machines where the eggshell temperature can be measured automatically, or they just simply measure the return air temperature. And Chickmaster has also a system, the Rock Control, which you can ask more information from the Chickmaster people. So always remember, and this is important, that your eggshell temperature or your embryo temperature will be different than your machine temperature. So as incubation progresses, you will actually have to lower your machine temperature to keep the embryos at the nice recommended temperature. So again, as I said, incubation manufacturers have a lot of tools these days. And if you have a Chickmaster hatchery, you probably have a Maestro where you can actually track your incubation profiles, actual temperatures, actual humidities, actual damper settings, or actual CO2 control measurements if you have that option, as you can see here. What I see during my visit, this tool is not used enough by hatchery managers. This can give you a lot of information. It also tells you how much your machine has to heat or has to cool. It actually tells you exactly what's happening, and you can learn a lot from this. It will also give you your temperatures in the different zones in the machine, making sure you are at the right temperatures. In this example, you set 0.997. Evidently, the machine is still warming up. So you sit in front of this and learn, what is my machine doing? Multi-stage. In multi-stage, that works on a constant temperature set point, as we heard before. But again, eggshell temperatures will be different at the start compared to later stage embryos. There is no way around it. So we still have to try to keep those temperatures in an acceptable range. Not easy these days, but not impossible. I don't think you can keep your eggshell temperatures below 101 at the late stage in a multi-stage machine, because there is several reasons for that. Is incubation duration different between the breeds? And this is really what the talk was about. So therefore, we do some hatch time trials. And if we look at the three breeds, Arbor Acre, Ross 308, and Indian River, when we put them in the same machine, same flock age, same egg age, there is no real difference. They tend to hatch and incubate at the same time compared to each other. However, if we go to the Ross 708, which is our heavy breed, compared to the Ross 308, which is our most famous breed, we do see a difference. We actually see that the Ross 708 will hatch 4 to 6 hours earlier. So it starts pipping earlier, but it will also hatch earlier compared to the 308. If we look at accumulated times, again, it is very clear that this breed is hatching and incubating on a quicker pace compared to the 308. But another question, is there always a total time, and I say total time difference between breed? Ignore the green line, but just look at the blue and the 308 line, which is red. Blue is 308 AP, one of our popular breeds in Latin America, also in India. And then we have the 308. When you have a close look at this, the AP will start its incubation a little bit slower than the 308. Probably not much, probably 2 to maybe 4 hours, a little bit slower. However, if we look at it closely, it will catch up at the end. So this means that our 308 AP might start hatching a little bit slower than the 308, but then the hatch window is much tighter and they will end up incubating at the same time. But again, the difference between the two is small, but it tells you that during the hatching phase, you need to be careful and you might have to ventilate a little bit earlier with your AP compared to the 308. And I say this because there is a lot of people changing over from a 308 to an AP now. Again, if we look at it here, we can actually see that the AP is slower, as you can see here, compared to at 480 hours, we have less chicks, 486, again, a little bit less. 492, it's starting to catch up. By 498, it actually almost caught up with the 308. So I thought this was very interesting and important to know. Male line influence. Is there an influence of the males? So as you know, at Aviagen, we have our specialty males. So what we did, we crossed the same female line 708 with different males. And we compared the hatchability, the hatch time, I mean. And there we see, again, probably little to no influence on the males over the females. So if we look at it, maybe the 344 is slightly faster in the beginning, but in the end, they all hatch at the same time. So there is not much difference of the males over the same breed. So the 344 is our classic Ross line. The EPM is an efficiency male, and the YPM is also an Aviagen male. A lot of people confuse this. This is not a Hubbard male. This is all Aviagen lines. So other factors apart from temperature and strain affecting incubation time, and this has been mentioned before, is definitely your flock age. So if we go young flocks and older flocks, they will need approximately 6 hours more incubation time compared to a prime flock. Egg age, same. As egg age increases, we need more incubation time. Rule of thumb here is after 6 days of storage, you will probably have to add about an hour of incubation per day of storage. And then, of course, fertility. If we have a very high fertility flock compared to a low fertility flock, those embryos from 10 days onwards will produce a lot more heat. And we have to manage that in the machine. If we don't, we end up with high incubation temperatures, and it will cost us hatchability and it will cost us chick quality. Another important thing to look at inside machines is machine temperature unevenness or evenness. So this is also very important. We can have different temperatures within the same machine, and this can be caused by different things. For example, a fan in your machine runs slower than another fan if you go into a multi-stage chickmaster machine. This will affect the airflow. If the airflow is affected, it will affect your temperatures. So you have to check these things. If you see differences, ask yourself the question why. Don't just go and change set points. You have to ask yourself why. if you have two identical machines next to each other, people will tell me we have two identical machines. I understand, but one might have a problem with heating element, the rotations of your fan, anything can actually make a difference. So you have to make sure that those temperatures are even. If not, you have to go and find out why. If you also load your machines in an unbalanced way, for example, a single stage machine, and on the left-hand side, you put high fertile eggs, and on the right-hand side, you put low fertile eggs, you will have a difference in incubation temperature. Also, the size of your eggs. So you have to balance them thermally, but also size-wise. So we think it's all in one cabinet and it has the same temperature. No, you need to be careful. And another big one, as I said, you have two machines next to each other. They have different temperatures. Why? It could be as simple as incorrect calibration of those machines. So the other thing, and I talked about turning angles, as I said, if turning angles are uneven, you will change the airflows within your machines, okay? And then another, last but not least, is your maintenance. We don't like to see gaps under the door seal. We don't like to see gaps in your fan boards and the multi-stage machines. We don't want to see low turning angles. So maintenance is very, very important. Again, it all ends up with having the right airflows within your machines, okay? So then we get also a lot of questions about modern broilers and heat production during incubation. So is that embryo heat production of a modern broiler higher compared to 20 or 40 years ago? We hear this a lot. Do we really know? Is a very important question. Is the embryo heat production compared between breeds very different? There's another question, and we hear these things. We need to check on that. So Dr. Nangswai, who's a good friend and used to work with us, she did a trial sponsored by Aviagen and our main competitor. And it didn't really show a significant embryo heat production difference between the two breeds. In the end, we see that we were slightly higher at the end of incubation compared to the competitor. But the interesting point here was too, that we see that the internal pipping of the chicks for both breeds was the same at 466 hours, which is very interesting. But then the external pipping, as we can see here, we see that the competitor was about a little bit over 4 hours earlier to us. So when you see these things, you need to ask yourself why. So one of the possible reasons here was the eggshell conductance. So we might have a difference between our breeds, but we also have a difference with these two breeds we see here. So if the conductance is different, that could be one of the reasons that there was an earlier external pipping. So in this case, it is suspected that the CO2 could not get out of the shell that easily with a competitor compared to us. And therefore, we know that when chicks feel that CO2 levels are too high, they want to get out of that shell. So don't take conclusions, it is this or that. We really need to dig into this, and we still have a lot to learn. So why do we hear so much about more heat being produced by the modern broiler? Well, I think the main reasons that we have more heat in our machines is because we have much better fertility than what we did 20 years or 40 years ago. So, as I said before, embryos will produce heat during incubation. If we have more fertile eggs in the machine, we will produce more heat. And a lot of our customers are still working with old machines. And these machines are not designed to cope with these high volumes of heat. They also increase the capacity in the incubators. For example, if you go in a high density tray, which is very much trying to be sold these days, that is fine to me, but you need to have the cooling capacity for those higher capacities, okay? We're trying to squeeze in more eggs per cubic meter. And of course, upper management will try to put as many eggs as possible in the same size hatchery they had 40 years ago. But we need to make sure that the machines can cope with this. And Chickmaster and other companies, they have the capacity. They know how to do this. So be careful and think about it. Okay, most of your heat is produced by better fertility and more eggs in the same incubator. Now, if we go into the hatchers, as said before, you need to adjust your set points according to your chick vent temperatures. Okay, so we know that the ideal chick vent temperatures are 103 to 105 Fahrenheit. Okay, 39.5 to 40.5 Celsius. This is the most important critical thing to look at in your hatcheries. Keep those chicks comfortable, okay? And you need to increase the ventilation once the natural created humidity levels are starting to drop, okay? Because that high humidity and temperature can be a danger for your chicks to hatch properly at the end of incubation. And we also want to control CO2 levels. We know that high CO2 levels during hatching can be damaging the chicks. So I would always say, try to keep it below 3,500 ppm at the end of your hatch. And when I say 3,500 ppm, I know it's going to be slightly higher in the baskets, okay? So keep it tidy. Again, Chickmaster can give you a lot of information on this. And then the Maestro Hatchery Management Tool, again, if you have it, use it. It will actually tell you exactly what's happening in your hatchers, and then you can manage. This is the set point at transfer. And then as you can see, the hatch bubble, as we call it, the humidity starts to rise. We know the chicks are to pip. We come on this high level, we increase ventilation, and we decrease set points to keep the chicks comfortable. Now, in the beginning, we see we're heating. Towards the end, we cool. Again, you can also have the option on how to measure your the CO2 levels. You can really fine-tune your hatch. So when you go into a hatchery, measure your eggshell temperatures, in the hatches, measure your eggshell temperatures when you transfer from your incubator. I can't give you guidelines here because this will depend on the kind of hatchery you have, okay? But you keep those eggshell temperatures around 100 degrees Fahrenheit all the time. This is the main message. And then once the chick hatches, you keep them comfortable as well. So, conclusion, observe, measure, and adjust accordingly. I can't give you numbers here. And I really want hatchery managers to think about what they're doing in their hatcheries. If I give you numbers, you will try it. And then you might tell me it doesn't work because I don't know your geographical location. I don't know your climate. I don't know your machines. I don't know your ventilation. And ventilation set points like static pressures in your rooms, these are depending on make and machine. So you ask Chickmaster and they can help you with this. So in brief, the genetic potential is there. We know it. We sell it to you. It's the best. And you are the person who can bring it out of the chick. So when you're a hatchery manager, breathe, live, and feel your hatchery, and you can bring out real nice chicks who will perform and make your company a lot of money. If you want any of our hatchery tips or how-tos, please go to our website, and it will give you all the basics on incubation when you read the how-tos and the hatchery tips. I started these back in 2013, I think, is there because these are about common problems we see in your hatchery. So thank you for your attention.
That's great. Eddie, thank you. I appreciate what you said about the influence that the hatchery manager has and that they should be observant of what is happening, to take measurements, to adjust, and to use the tools at their disposal. And certainly now the additional knowledge they have at their disposal to get the most out of your breeds. We know that, and I agree with you completely, that every site is a little different, and the conditions under which they're trying to incubate with their particular lines in their particular ventilation settings. And so this is why our companies all have hatchery specialists, hatchery consultants to come alongside you and help you. And so feel free to reach out to us at Chickmaster, or certainly if you are a Cobb or an Aviagen customer, you can reach out to them to talk about your particular site. And we're going to work together to try to help you get the best out of out of your site. So you can always reach out to anyone you know at Chickmaster or email us at support@chickmaster.com. If you email us at support@chickmaster.com, we can get a hatchery specialist. We have them spread all over the world. We'll have someone reach back out to you to talk about your conditions. We can also give tips on how to maintain, how to do pre-checks, and how to do maintenance tasks on single and multi-stage equipment. And so being able to put into practice the principles that Tommy and Eddie have laid out for us, the Chickmaster staff can help you figure out how do you adjust your stage programs? How do we get that turning back to where it needs to be if you have an aging machine? Any of those kind of things. We'll work right alongside you to make sure you're equipped to do what you need to do. We win. If you win, we are your partners here and want to make sure we help you. Let's see, Chad, once again, I want to give you an opportunity. If you have any comments from your experience with the Aviagen or the Cobb line, or if there's any of these other questions that you think are valuable to our whole audience, why don't you go ahead and field those? Otherwise, I'll let you make any final remarks and close us up.
Yeah, again, obviously, thanks, Tommy and Eddie, both for the great presentations. The great response from everyone. Some really good questions that are very detailed and specific to the breeds and things of that nature. So thanks so much to everyone for being involved with this webinar. It was a wonderful webinar.
So with that, thank you to everyone. Thank you to all of our guests. And we're signing off here from Chickmaster. Thank you again. Take care.